All right, so we're going to keep the notes pretty short today as we kind of just sort of ease into things here. And what they're primarily going to focus on is just some vocabulary and some of the language that we use in a statistics class. Because words that you use in like everyday life might have a different meaning when we're talking about them explicitly in a statistics course. All right. So first example of that would be the word individuals. So obviously we all use that word. We know what it means. But it has like a specific definition when we're talking about it in the context of statistics or a statistical study. So individuals are objects described by a set of data. So if you have a table full of data, the object that that data is describing is the individual, right? It doesn't necessarily mean a human. Individuals may be people, which is kind of the normal understanding, but it could be places. All right, a place could be an individual in the context of talking about statistical study. It could be, objects or things. So, more or less like nouns. Like you could have a data set on houses. And then those houses would represent the individuals of that data set, the object that we're describing. All right. So again, a word we're all familiar with, but just knowing when we use it in a statistical setting that it's kind of referring to whatever we're describing with our data. All right. So next word that you've probably seen, and you've definitely seen, or if you haven't seen, that's really weird. Variable. So not talking about X, Y, and things like that. Instead, the variable is a characteristic of an individual. I just hit my webcam there, which sort of screwed everything up. So let's see if we can get this back. Something good. Characteristic of an individual. And it takes different values for different individuals. All right. So just kind of thinking about this more, like, again, the individual is what you're describing. The variables are the different things that you've collected data on. So let's just say, houses, again, we'll go back to that example as your individual. A variable might be the acreage that the house is built on. It might be the number of bedrooms that are in the house. It might be the number of bathrooms. Those are the different characteristics that we can then gather data on, and that those characteristics are going to take different values. So anytime in this class that I give you a data set, there's questions that you kind of want to be asking yourself. So anytime that you get new data in this course, the things that you want to be considering are, who are the individuals? All right, so who is the data set describing, or what is the data set describing? And then what are the variables? And with variables, it's also important to know and in what units, right? Because presumably you're looking at the data because you want to reach some conclusion or you want to analyze some situation. So before you can do any of that, you kind of have to just have a handle on what you're looking at and the context of it. So for example, if you have something like GPA, what's the scale that it's being measured on? Is it a 0 to 100 scale like we use in high school? Is it a 0 to 4 scale that they use in college? Or is it something else entirely? But without having sort of that background information, you can't accurately analyze the data. So again, a lot of this kind of common sense, but we're just putting some formal terminology around it. So let's just kind of break down an example that we might see in sort of like a school setting. A school database has individuals, it has variables. So Ichabod Crane keeps a school database. We primarily do it through School Tool, and that database contains all sorts of information. There's actually multiple individuals that database keeps, information on, but the main individual in the context of a school would be you, the students. All right. Now there is information on teachers, there is information on administrators and things like that, but the main source of information is on the students. And then the variables could be all sorts of things. All right. It could be things like GPA that we already mentioned. It could be your zip code, where you actually live. It could be the classes that you take. It could be your year of graduation. All of these are different characteristics of a student. Right? And they can all take different values as you change to different students. So these are the variables that describe the individual, which in this case is the students. So again, just kind of getting comfortable with this vocabulary so that if you hear me use these words, you can kind of put them in the context of what I'm actually talking about. So when I say variables in this class, I'm not talking about X, Y, Z. I'm talking about characteristics. When I say individuals, I'm not necessarily just talking about humans. I'm talking about whatever the data set is describing. So just making sure we're all on the same page when we do that. Now, with our variables, they generally get divided up into two separate groups. All right. And these two separate groups we're going to see throughout the entire course are generally handled differently. All right. We calculate different statistics. We create different graphs. We run different tests. Pretty much everything we do in this class, in almost every unit, we almost have to do it twice. We have to do it once for categorical variables and once for quantitative variables. All right, so this is going to be kind of a dividing line for almost everything we do in this class. So let's just get some sort of formal definition downs of what qualifies as a categorical variable and then what qualifies as a quantitative variable. All right, so categorical variables places an individual into one of several groups or categories. All right. So, for example, what's a good example? If I was to ask about hair color, right? We would create different groups, brown, blonde, red, black, any mixture of those that you want to make, but they're distinct groups and each person would be placed in one of those groups. All right, you can do the same thing for something like eye color, things like that, where you're creating distinct groups and the individual is either part of that group or they're not part of that group. But it's kind of like a yes, no type situation or a true, false based on whether or not they exist in that group. All right. In contrast, a quantitative variable takes a numerical value, and this is the key part, for which it makes sense to calculate an average. All right, so what do I mean by for which it makes sense to calculate an average? Easiest example here is something like a zip code. A zip code is a numerical value. All right, the school is in zip code 12184. That said, it does not make sense to, that doesn't look like numerical. It doesn't make sense to calculate an average zip code. You wouldn't say like, oh, on average, this class lives in zip code 12137.64. Like, it's nonsensical. So the obvious part of quantitative variable is that it needs to be a numerical value. The less obvious part is that you also have to be able to calculate an average from those values. And not only calculate it, but calculate it and have it be meaningful, have it actually mean something. Whereas a zip code, yeah, you can calculate it, but it doesn't mean anything. All right. Other examples, identifiers, is when a number is used to represent an individual or some attribute. All right. So sometimes you can code things with numbers. And I could be like, all right, anybody with brown hair is a 1. Anyone with black hair is a 2. Anyone with red hair is a 3. But again, that doesn't turn something into quantitative data just because I put a number on it. You still kind of have to ask yourself, what is the nature of that variable that they're measuring, and is it a categorical situation or is it a quantitative situation? Another point here, sometimes categories are disguised by numbers. All right, so what do I mean by that? All right, so for an example, first example would be zip code that we already said. Zip code is really a categorical thing, but it looks like a number. The other one that usually gets used a lot is something like an age range, or really any sort of range. But like you'll be taking a survey, and instead of asking specifically for your age, which is a quantitative variable, right? It's numerical. It makes sense to calculate average age. Like the average age in this class is probably like 16, 17, somewhere in that range. An age range, even though it seems quantitative, is not. And let me show you what I mean by like age range. So on a survey, it might say like, what age range do you fall into? And then it might give you like, oh, are you 15 to 20? Or are you 21 to 30? Or are you 31 to 40? And so on and so forth. By switching it to a category, you lose the ability to calculate an average. Like once I get all of my responses back, I have no way of calculating an average from those responses because I don't know when you checked this box, are you 15? Are you 16? Are you 17? Are you 18? Are you 19? Are you 20? I don't know what your age is. So because I've lost that ability, it's no longer considered a quantitative variable. All right, this would be a categorical variable because I grouped together quantitative data, which then has the effect of turning it into categorical. All right, so this, even though it looks numerical, is technically categorical. All right, so again, for the most part, it's a pretty common sense distinction. There's just a few cases around the edges where it's like, oh, okay, like I see why that makes sense. Like, yeah, I would have thought that would have been this, but now that you explain it, I see why it has to be that. And it's things like, again, zip code, ranges, things like that, that just not intuitive. But then once you think about it for more than a second, you kind of understand why it has to be in that categorical area. All right. So last but not least here is the word distribution. All right. So distribution, I'm assuming when you hear that, you think probably about things being passed out or handed out. Okay. It's kind of what's going on here. For us, distribution specifically means it's generally when we're talking about variables. So the distribution of a variable tells us what values the variable takes and how often it takes them. Okay. And a lot of times when we're talking about distributions, we're going to represent them like visually. So, for example, if I was saying, what are the ages in this class, I would figure out, what are all the different values, 15, 16, 17, 18, and then however old I am. And then how often do each of those values occur? Like how many people are 15? How many people are 16? But it just gives you kind of a summary of everything that exists in the data set. What are all the possible values? And then how often do each of those values occur? All right. And we're going to spend a lot of time looking at different distributions, describing distributions, figuring out what they tell us and what they don't tell us. All right. So again, that's kind of just, a brief introduction to some of the terms that we go into. I hope this was helpful. And obviously, if you have any questions, feel free to pop into the Google Meet or just send me an email. All right. Good luck.